This is lecture P2, instructions for graphing parametric equations on a graphing calculator. This matches up with pages 3, 4, and 5 in the note packet. On page 3, you have directions on how to graph numbers 4 through 14 with hints on some of those problems. We're going to be referencing pages 4 and 5 in this lecture video. So page 4 of the note packet has instructions on how to find the window values for t, x, and y, depending on the type of equation you have. So the first thing you need to do when you're asked to graph a parametric equation is to determine if it's type 1 or type 2. If we're looking at the two equations given to us, type 1 equations are always going to have our parameter t contained inside of a trig function. It could be any trig function. Sine and cosine are the examples here, but it could be tangent, cotangent, cosecant, and secant. So if t is contained in a trig function at all times, in the way that we define x and y, we have a type 1 parametric equation. If we see in the definition of x or y, t is outside of a trig function, so in this example for type 2, 2t plus sine t is how we define x. Because t is not inside of sine, cosine, tangent, cosecant, secant, etc., that means that this is type 2. And what happens is when we go to find the minimum and the maximum for x, we end up with negative infinity to infinity because t can be anything. Whereas in the type 1 situation, we have upper and lower bounds. That's what separates out the two different types. So once you've determined what type of parametric equation you're working with, you're going to follow whatever set of rules that goes along with the type. So in an example of type 1, you're going to follow these 4 steps. And then type 2, you'll see on page 4, there's a box with the instructions there. So we're going to start by focusing on type 1, and I'll walk us through all the 4 steps for a couple of examples first. So if you turn to page 5 of your note packet, number 1 at the very top, we want to follow the steps on page 4 for type 1 in order to find the correct windows, and then we'll sketch the graph using our graphing calculators. Okay, so number 1 on page 5, this is a type 1 parametric equation. If we look at the way that we've defined x and y, t, our parameter, is contained inside of sine, cosine at all times. So this is where we have a type 1 situation. So we go back to page 4 when we reference the steps for type 1. First thing we're going to do is we're going to find the t values by determining the period of each of the terms. So we're going to look at each of these terms separately. So just kind of ignore the fact that they're all together, and we're going to lock in on the period. So we need to figure out the period for each of these terms separately. Now, the standard period for sine and cosine is always 2 pi. That 5 on the outside here, that's our amplitude change, so that doesn't impact the period of these two terms. But when we move on to the second two terms, in x and y, the cosine of 5t, that's going to change the period to 2 pi over 5. Remember that it's the standard period divided by the frequency. In this case, our frequency is the 5 on the inside with t. So first rule for our window values is we're just going to pick the biggest period of the 4. So in this case, 2 pi is our largest period. That means that our t values are going to go from 0 to 2 pi. It's always 0 to the largest period in type 1. Next up, we find the y min and the y max and the x min and the x max, and then we'll use some of those values to determine the window ranges for our graphing calculator. Now, just like we did the periods, we're going to look at each one of these terms separately and kind of determine the minimum and the maximum for each. So in our top definition of x, that first term, 5 cosine t, that has a min and a max of negative 5 at 5. The cosine of 5t, negative 1 to 1. We go down to the bottom, 5 sine t goes negative 5 to 5, sine 5t, negative 1 to 1. We're looking at the amplitudes here in order to give us the minimums and the maximums. Now, the actual min and max for x and y then is some combination of these two values. So if we're looking at the actual min and max for x, all we're going to do is combine the minimums here. So our actual minimum for x is going to be negative 6. Our actual maximum for x then is going to be 6. And the same thing for y. We look at the two minimums, combine them, look at the two maximums, combine them. So those are the minimums and the maximums for x and y. Go back to our directions on page 4. And step number 2 for type 1 says, once you find the y min and the y max, we use the min and max for the window values. So we're going to use negative 6 and 6 for our y values. Now, our graphing calculator is not a square screen. It is more long than tall, so we've got to maintain that 3:2 ratio. The last thing we're going to do to find those x values then per the instructions in step 3 on page 4. So we're going to take those y values and we multiply by 1.5. And that's to maintain the 3:2 ratio x to y axis in our graphing calculators. So that's going to get us negative 9 to 9. And then the very last step for type 1 on page 4 says make any necessary adjustments. So the one thing we're going to check is we want to make sure that the actual min and max that we determined for x is satisfied in the window range for x. So in this case, negative 9 to 9, the window range that we've chosen, it does fit negative 6 to 6. So we're good. We don't need to make any adjustments. We're going to go in with our graphing calculator and we're going to figure out how we graph this. Okay, so we're going to go into our mode here, and we need to change our calculator into two things. Make sure we've got radians, and we are going to be on parametric now instead of function. When we are in that right mode for parametric, we are going to click the y is equal to, and we now see two places to write an equation, one for x, one for y. So for number 1, we've got 5 cosine t. When you use the variable button now, it turns into a t instead of an x minus the cosine of 5t. And then 5 sine t minus the sine of 5t. Before we hit graph, we're going to go in and we're going to adjust the windows per the values that we had set. So our t min and t max, 0 to 2 pi. 2 pi should already be there. And then our calculators are going to put the t step at 1.13, and that's just a good value. You can leave that. Now we said our x min was going to be negative 9 and our x max was going to be positive 9. Scaling by 1 is good here, negative 6 to 6 for y. The scale is just how many, like what each tick mark on our axis means. Once we've got the window values that we found, we're going to hit graph, and we should see a good ratio on your graphing calculator. On my screen is going to be a little bit different because I can adjust the screen size. But you should get something that looks like this, and then we're going to transfer those points onto our graphs from our graphing calculator and just do a sketch. Okay, so everything else coming from the graphing calculator is really just a basic sketch. So I'm going to situate my x and my y axes in here, make sure that I label them, and then we're just going to use our graphing calculator to kind of help us sketch this out. So it looks like we go up and down and left and right about 4. And then we can also look at kind of those like maximums of the clover, kind of guesstimate where those fall. It looks like 3, 5, negative 3, 5, negative 3, negative 5, and 3, negative 5, something like that. And it's just really a basic sketch after that. So we're just going to draw in the sketch of this. Majority of the points here are going to come from actually finding the correct window values. So once you've got it in your graphing calculator, you check that your windows satisfy all the information, and then just sketch the graph. All right, so we're going to look at number 2 here on page 5. We're going to identify the type first. Now, this one's a little bit tricky because we look at the two equations here for x and y, and t, our parameter, is still contained within trig identity or trig functions. So because t is inside cotangent and inside sine squared, this is still a type 1 equation. So we're still going to follow the type 1 steps. We're going to have to make some exceptions here, though. So let's start first by determining the periods. The standard period of cotangent is pi. Now, the standard period for sine squared is also pi. Remember that when we graph sine squared, we don't have any negative values. So what would be a negative value in regular sine actually has to come up and become positive when we square it. So we have the period in that case. The period for sine squared is pi, just like the period for cosine squared is pi. So if you ever see that, pi is our answer there. So that means that the window range for t is 0 to the biggest period, in this case 0 to pi. Then we go in with the actual mins and maxes for x and y. So if we're looking at cotangent here, 2 cotangent t, the maximum for cotangent and the minimum, negative infinity to infinity. It's all real numbers there. That's different than the last example we did. Now, for the minimum and the maximum for 2 sine squared, again, if we're looking at a sine equation, remember we're squaring all of this. We have to raise everything that's negative to be above the x-axis. In this case, instead of negative 2 to 2, we're going to have 0 to 2 as our min and our max. Now, rules for type 1 equations say that we take the actual min and max for y, and that becomes the window range for y. So 0 to 2 is going to be our y values there. And then the rule says that we take those y values and we multiply by 1.5 to maintain that 3 to 2 ratio in order to get the x window range. Now, that would give us 0 to 3. The problem with this one is that range, 0 to 3, does not encompass the actual min and max that we found from 2 cotangent t. So we have a problem. The range that satisfies the 3 to 2 ratio, not satisfying the actual min and max of x. So this is where step number 4 on page 4, make any necessary adjustments, comes into play. There's an exception that we have to make here in order to satisfy that minimum maximum for x. So instead of following that 3 to 2 ratio, we're just going to pick some nice values that are going to give us a clear vision of the graph that we can sketch. So I'm going to go in with negative 10 to 10 as our min and max in the windows. You could do negative 20 to 20, negative 15 to 15, something that makes sense like that, so that we can get a good idea of what the curve of this graph is going to look like. So we're going to take those new values, 0 to pi, negative 10 to 10, and 0 to 2. We're going to plug those into our graphing calculator along with the 2 equations here, and we are going to sketch the graph. Okay, so then going in with this second equation, or the second problem, we are going to type in a couple of things here. Now, we don't have a cotangent button, so we have to use tangent in order to represent cotangent. So when we go in to define our x equation here, we're going to do 2 divided by the tangent of t. That is 2 times the cotangent of t. So just be careful how you're typing that in. Now, more importantly is actually how we type in the second equation for y. Sine is the only thing being squared here. So I'm going to put that sine in its own set of parentheses and then square that. If you include the 2 inside of that parentheses, you will be squaring the 2 as well, and then your window ranges that we found are not going to be right. So we want to be really careful, especially about typing in sine squared, cosine squared, all of those things. So be careful, pay attention. Before we hit graph, we're going to change those windows. So in the case of number 2, we said that t was now going to be between 0 and pi. So we need to change that. Again, 0.13 for radians is a good way to count. Now, we're going negative 10 to 10 on our x min and max. And again, that's because we had to make that adjustment. If that didn't work out when I hit graph, you could then start to adjust the x values to kind of fit better. And then 0 to 2 was going to be our y min and our y max. And if we hit graph, we see something that looks similar to a witch's hat maybe, and that's where the name is coming in. So we're going to transfer those points onto our graph and kind of just sketch it. We're really just going to pay close attention to the maximum there at 2 to try and get a good curve. All right, so coming from the graphing calculator, I'm going to scale that y-axis probably by a quarter. 1, 2, 3, 4. 4 up is going to be 1. And just kind of eyeballing our graph here, we kind of hit that maximum at 2, and then we get to preserve the shape here. And then it's just going to be kind of a sketch of the graph, just like that. Again, the majority of points are coming from identifying the correct window ranges and not necessarily the sketch of the graphing calculator. All right, so the very last example we're going to look at in this lecture video is going to be a type 2 equation. So with type 2s, remember again, t, our parameter, is no longer going to be contained inside of sine, cosine, tangent at all times. So we're going to see that in example 3 here. And we are going to follow a different set of rules for type 2 equations to satisfy that all real numbers min and max for the x equation. So we're going to look back at page 4. Type 2 has its own set of instructions here. We're going to find the y min and max using that equation. Then we're going to find the t values. And then we're going to use those t values to actually help us find the x min and x max this time. We're not going to be worried about preserving the 3 to 2 ratio because we're going to see our graphs go forever in the x and the y direction. So we're going to end up limiting the number of cycles that we graph with our graphing calculator. All right, so number 3 looks like this. We've defined x as 2t plus sine t and y as 2 minus cosine t. Now, here's the deal. That 2t that's sitting out in the front, that's what makes this a type 2. We don't have t contained in sine or cosine or tangent, and so we're going to see that the actual min and max for x is negative infinity to infinity. But then we focus in on the y values, and we're looking for the actual min and max of y. Now we're going to look at the min and max of cosine t. -1 to 1, that's our general negative cosine or cosine t graph. We have this constant sitting here though, so the actual min and the max is going to be 2 minus -1 and 2 minus 1. So when I combine that constant with our minimums and our maximums, what we end up with is a minimum of 2 minus 1, which is 1, and a maximum of 2 minus -1, which is 3. So going back to page 4, the first step is to find the y min and the y max and then use that for our values in our windows. Now we have one problem here, so another exception that we have to make. This would cut off, this cuts off the x-axis. So we always want to see both x and y axes, which means that we are actually going to drop the y minimum down to 0 when we go to actually express our window values. We want to be able to see both axes at all times. 1 to 3 does not do that for us, so we're going to move that down to 0 to 3. That's our y min, our y max. Then we move on. In type 2, we have a different set of steps here. So we're going to find the t values by determining the period of each term that has a trig function. So kind of going back to what we were doing in the last set of examples, but we're going to do something different with t this time. So 2t, not going to have a period. 2, also not going to have a period. So we're really just focusing on sine and cosine. Period of sine and cosine here, our standard period is 2 pi. Now, in this example, I want to graph 2 cycles. So what we're going to do, if one cycle is going to be 2 pi radians, I want to make sure that we include 2 cycles. So we're going to go 0 to 4 pi radians. That's going to be our t lower and upper bound. And then the last step here, step number 3 in type 2 on page 4, we're going to find the x min and the x max, and we're going to do that by using those t values. We're going to plug those t values in to the equation for x, and we're going to get our x minimum and our x maximum. So when t is 0, we get 2 times 0 plus the sine of 0. I'm just using the x equation, and I'm replacing 0 for t. Now what happens is we get 0 plus the sine of 0, which is also 0. So our lower bound for x is going to be 0. I'm going to do the same thing with 4 pi next. So 2 times 4 pi plus the sine of 4 pi. Well, that's 8 pi plus 0. So our upper bound for x is 8 pi. 0 to 8 pi is our window values for x. All right, we're going to move all of this over to our graphing calculator, and we're going to take a look, and then we'll get it back on the graph. Okay, for number 3, I've got to use a different calculator here. I'm going to go back and clear out the equations for number 2, and we are going to type in the equations for x and y. So we've got 2t plus sine t, and we're going to have 2 minus the cosine of t. I'm going to go into the window values and we're going to adjust. So now for number 3, we're graphing 2 full cycles. So we wanted 0 to 4 pi. 0.13 for our t-step is fine. Our x min and max was 0 to 8 pi. And I'm going to come back to that x scale in a minute, but I'm going to go in with the y min and max first. We picked 0 to 3 for the y min, y max. Again, remember, we dropped it to 0 so we could see the x-axis. And that y scale of 1 is great because we're counting integer values from 0 to 3. 1 is a good scale for the y-axis. Before I change the x scale, let's just look at what happens when we scale by 1. So if I hit graph, there's our curve. We have 2 full cycles because we've got 2 full iterations of that curve there. And as we see on the x-axis, each one of those tick marks is 1. And it's really hard to see here because it's so small, but they don't really line up necessarily with an x min or an x max or like a maximum or a minimum on our graph. So I'm going to go back and I'm going to adjust the scale in my windows to see if we can get better points that are easier to graph. So I'm going to go back and hit window, and instead of scaling the x-axis by 1, I'm going to be strategic here. Our x min was 0, our x max was 8 pi. So I'm going to start by scaling by pi. And if we think about this or reason it out, if we're scaling by pi and we're going from 0 to 8 pi, we should then see 8 tick marks along the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. Great. So each one of those tick marks along the x-axis now represents pi. And if we look at 2 pi, we have a maximum. And then at 4 pi, we have a minimum. And then at 6 pi, we have a maximum. And at 8 pi, we have a minimum. So pi is a really good scale for the x-axis here. And also, it's an easy way to just plot points on our paper really quickly, without having to worry too much about trying to count by weird numbers. Okay, now that we've got that on the graphing calculator, I'm just going to transfer those points over. I'm going to scale my axes so that they match up a little bit nicer to what we saw in the graphing calculator. So I think I'm going to scale the y by 1/2. I probably could have done 1/3, but that fits. And then along the x-axis, I think I'm going to count by pi over 2. So that's going to be something like this. Okay, so we're going all the way to 8 pi along the x-axis. Right, that matches our windows that we've chosen for 2 full cycles. And then we're just going to transfer some of the points from our graphing calculator. So looks like 0, 1, and then 2 pi, we're going to be at a maximum of 3. 4 pi will be back at 1. 6 pi will be at a maximum of 3, and then we'll be back at 1 at 8 pi. Remember that our minimum for y was 1 and our maximum was 3. And then we're just going to kind of sketch the curve here. Make it look nice. Nicer than mine. Okay. Something like that. That's the difference between type 1 and type 2. Type 2, we are only going to graph a finite number of cycles, whereas type 1 graphs, they're already contained. So no cycles to have to worry about there. So just read the directions. I might change the number of cycles that I want you to graph. If I don't specify, then try graphing 2. My last hint to you as you start working on your homework assignment is number 14 on page 5 is a little bit weird. This is one that has like a bunch of exceptions. So just put it in your graphing calculator and play with the window ranges until you get something that kind of works for you. And there's more details on that on page 3 of your note packet. Numbers 1 through 14 on page 5 is the homework that goes with this lecture. Email me if you have questions.